So, welcome to this video where we will see how we can enable workload management in vSphere and we'll use the vSphere networking topology. So, in a previous video we discussed how to deploy an Avi controller for us to be able to use the NSX Advanced Load Balancer, which is one of the supported load balancers when using vSphere networking in Tanzu. So again, the support for the Avi load balancer came in vSphere 7 update 2, so you need to be on that version to be able to use it. If not, you're stuck with the HA proxy, which is a fine alternative, and it is working also. So, but we have an Avi controller deployed. It has the networks set up. So we have the management network, the lab 100 network, which will be the management network. We have the lab 162, which will be the front end or the data network. And this is where the service engines for Avi will live. And this is where the load balanced IP will live, the virtual services. The workload network will be on the lab 161 network. To be able to come from the virtual network, which is created for the service engines, the 162 network, and for it to reach the workload network, namely the Kubernetes control plane nodes, we need to have a route for that, which is set up, and we have this workload network subnet will be routed through the gateway on the front end or the data network, the 162.1. So in Avi we can see that there are no service engines deployed, and then of course no virtual services either. But as soon as we go over to vSphere here, we select the vCenter server network option. We'll see that we have compatible clusters. We'll select the cluster 01. And of course we have met the requirements with DNS, DRRs and so forth. We will select the resource allocation for the control plane nodes. So I'll select the tiny one. We will select the storage policy to use. So in my case, I'll just use one of the vSAN policies I already have. And now we will point this to the load balancer. So we'll give it a name. So this is just a name. It needs to be DNS compliant. Give it the IP address of the controller. We'll give it credentials for logging in. And we also need to add in the certificate information for the controller. And this is why we need to create our own SSL certificate in this when we set up the controller. So we go over here into templates and security to list all the certificates, and we can hit that kind of the download icon to copy out the certificate itself and just paste that into this field. Now we select the management network. So again, this is on the network 100. And just want to stress that this is not the same IP range as we have set in the Avi controller. So if we head over to the networks here, we can see we have configured a static IP pool on the management network from 200 to 209, and this will be used for the service engines. So they will have one network interface on the management network. This IP pool in the vSphere or in the workload management will be for the control plane VMs, so the Kubernetes nodes. So we need to have a total of 5 addresses available, which needs to be on this subsequent range. So so we'll have one IP for each of the 3 supervisor control plane VMs or the nodes, and then one IP is used for a floating IP, which and then the last one will be used during upgrades. We'll give the subnet mask for this network, and then the gateway. We'll specify DNS server or servers. We will optionally set a DNS search domain, and then the NTP server. Now we'll select the workload network. Again, we will specify DNS servers, and please make sure that the IP addresses does not collide with anything else in your environment. And then we can add in the workload network. So this will be put on the 161 network in my case, which has a gateway of 1. And all of these networks must be routable, so please make sure that that's okay as well. 161. This network range will also need to be a CIDR range, so it needs to start and stop on a CIDR range. So 161.127. And we can add more workload networks if we choose to, and that is something you might want to do to have some boundaries between workloads in your environment. Now we need to point it to a content library, which I have already created, and this content library needs to have the OVAs for the Kubernetes control plane VMs, and we can have that subscribed to a upstream VMware content library if we want to. And then that's it. We can go ahead and finish. And the workload management will now start to configure the cluster, and also after a short while it will start to deploy VMs, which will be configured as the supervisor control plane VMs. So you can click on the cluster here. You can see we have got this namespaces resource pool, and there's 3 supervisor control plane VMs which are deployed automatically for us. So this will take some time. We can monitor the progress from the cluster monitor tab and the overview of the namespaces. Bear in mind that this error list will include quite a lot of errors and warnings while it is working. That's completely normal, so just let it be. Around 30 to 40 minutes maybe it will take, depending on your environment. And again, it will complain about a lot of errors during that time, but let it be, and then come back in 30 minutes to check the status. There is also a log file on the vCenter appliance we can follow if we want to see more status. And we'll come back to that later on when this has come a bit further. So I'll pause the video now. So we can see that the deployment is still running. The supervisor control plane VMs are now healthy. So we can see we have the 3 nodes. They are running. Currently the control plane node IP address is on the management network. This should later on be showing the load balanced IP on the data or front end network. You can see we are tailing the VCP log file on the vCenter appliance as well. So still a lot of warnings and stuff going on, but it is just, we still have to wait until everything has been deployed on both the workload management side and also the Avi controller. If you head over to the Avi controller at this point, we can see it has started by deploying one of the service engines. It is still down. In a few minutes it should start to, it should be powered on and initialized into the load balance solution. And we will also have to have one more of these, but this is handled automatically by the Avi controller itself. So I'm going to pause the video again. So our second service engine has been deployed and is up and running. So we can see that it does have a health score of 50, but that's also normal now in the startup phase. It will in a few minutes, hopefully it will reach up to 100. We can go and check our virtual service, and we see we have the service pointing to our Kubernetes API server. So we should be able to reach our supervisor cluster on this IP. We can verify that we in vCenter everything is up and running. The same control plane IP address is listed. So we'll head over to our shell and we can try to log in. So bear in mind that we have now we do have to download and install a plugin to the kubectl to be able to log in through vCenter. But what we can see now is that we do not reach this network, or to be precise, the network, the data front end or data network cannot reach back to our client. So even though everything is up and running and green in my environment, there is no way that the service engines, which lives on this 162 network, can reach back to the client network, because inside of the service engines, these are running, the management is running on the management network, but the data network is kind of a virtual IP network inside the service engine. So we need actually to tell the service engine which gateway to use to reach back. This is not documented properly, in my opinion, so this was a bit of a surprise. Everything seems up and running, it's green both ways, but we cannot reach the cluster. So what we need to do is to add in a route from this data network, the front-end network, and back to our clients. We can do that by either create a new route, so my client is living on the 192.168.1 network, and I'll route that through the 162.1 gateway, and I should now be able to reach my Kubernetes cluster. Oh, I need to use the correct context. And I get my 3 supervisor control plane nodes. So another way to do it is to, instead of adding routes to every network your clients live on, we could also add a default route or a default gateway. So with 0.0.0.0/0 and then through the same gateway, we see that the controller will edit the prefix and set it to default gateway, and then we should still have connectivity to our cluster. This will also make this this route obsolete. But this is kind of a gotcha for me. I was not aware of this, and this is something that is not properly documented in my opinion, so hopefully VMware will fix that. For many people that are testing the Avi solution, I suspect that they are using the enterprise evaluation, because in the enterprise edition there is a feature called auto gateway, which will fix this problem for us. Is documented, and in 20.1.1 a new enable auto gateway was introduced, so making this routing easier. But this is an enterprise feature, so keep that in mind.